Hi everyone, this is lesson 1-2, analyzing graphs of functions and relations. Our learning target will be today for students to be able to use graphs of functions to estimate function values and find domains, ranges, y-intercepts, and zeros of functions. This video will specifically focus on finding domains and ranges of functions. In example 2, we're going to find domain and range of the function. Use the graph of f to find the domain and range of the function given. Now, if you remember, we discussed that domain is the set of x values. Domain represents the x values of a function. And range represents the y values of a function. Okay, so here we are looking at this graph of this function, and we see that the graph moves infinitely downward as well as to the left. Okay, this graph is going to continually slowly make its way down and to the left. This end of the function stops at, is not continuous, it stops at x equals 3, if I'm counting by 3s on the number line here. So when we discuss our domain of this function, I always write my domain from least to greatest in interval notation. And my domain is going to go from negative infinity to 3. So my graph goes all the way to the left negatively. We're going to start our graph from negative infinity, and we're going to draw our graph or trace our graph until we reach an x value of positive 3. And since there's a closed hole here, we use a bracket to show that 3 is included in our domain. Now our range, on the other hand, since the graph is moving downward and our range describes the y values, the graph is going to go downward infinitely. So when I describe my range, the smallest y value I'll ever reach is negative infinity, because the graph is going to go down infinitely. And also, our highest y value happens to be a y value of positive 2. And since these are closed dots on the graph, we are also going to include 2 in our range. Now, you could write these intervals in set builder notation as well. I used interval notation. If we wanted to write our domain in set builder notation, we'd say the set of x such that x is less than or equal to 3, and x is an element of the real numbers. And a range is the set of y values such that y is less than or equal to 2. And y is an element of the real number system as well, because our graph is continuous along these values. In example 2, we're going to, part B, we're going to find the domain and range. Use the graph of f to find the domain and range of the function given. Now, what we're going to do is we're going to look at the graph first to determine the domain of the function. And the domain of the function, let's just call this x value right here, where it touches the x, where the parabola, or sideways parabola rather, touches the x-axis. Let's call that negative 5. And when we determine the domain in interval notation, we always list our domain from least to greatest. And so we're going to say the graph, the least x value on the graph is negative 5. And since the graph travels to the right infinitely, because we can assume these are arrows on the end of our graph, we will assume the graph travels to the right infinitely. So the domain would be from negative 5, including negative 5, all the way to infinity. Now, our range, because the graph is going up at the same time it's going to the right, right here, it's traveling up and to the right, And right here, this arrowhead is traveled to the right and downward. Because we're traveling downward infinitely here and upward infinitely here, since the range describes the y values and what's happening vertically on the graph, we would say the range of the graph, since this piece is going down infinitely and this piece is going up infinitely, would be from negative infinity to positive infinity. In example 2, part C, we're asked to find the domain and range. Use the graph of f to find the domain and range of the function. Now, we're going to assume that the graph is going to continue on in the direction it is moving. So we will put arrows at the end of each of these pieces of the function. Now, this piece is moving down. This part of the graph right here is moving down and to the left, so it's moving downward and moving to the left, just like this piece of the graph is moving upward and to the right. Because our graph is going to move to the right infinitely, right here, and move to the left infinitely, this direction, that tells me my domain is all real numbers. The graph is continuous. There's no breaks in the graph. I can draw this graph smoothly without having to lift up my pen. I could trace this graph without having to lift my pen up at all. Okay. When that happens, when I can draw a graph without lifting up my pen, we call it continuous. And any continuous function is going to have a domain of all real numbers, which means negative infinity to infinity in interval notation. Now, our range, on the other hand, our smallest y value, our least y value, since the graph is pointed downward infinitely, the graph is decreasing right here, or it's going downward. So I would say the function, the least y value is negative infinity, and since this arrow is pointed upward, we're going to say the function increases infinitely to the right as we move to the right. And so the greatest y value this will ever reach is positive infinity, because the graph is going to keep going up forever or infinitely, so the highest y value would be then infinity. This tells me my function's increasing to the right, and if I was moving toward the left, the graph would be moving downward towards negative infinity. If I were to write these domains and ranges in set builder notation, both the domain and the range, because it's negative infinity to infinity, would be the set of x such that x is an element of the real numbers. It's all real numbers for the range. And the range is the set of y such that y is an element of the real number system. So just to clarify this and make sure I said this correctly, the domain is the set of x such that x is any real number, and the range is the set of y values such that y is any real number. In example 2, part D, we're asked to find the domain and range of our function, and we're given the graph of a piecewise function here. And so our function is not continuous. There's two different pieces to it. I'm going to assume that there's arrows on the end of each piece, that the graph will extend upward and to the left infinitely here, and extend downward and to the right infinitely here. Now, because there is a break in our graph, that break because there's two different pieces of this graph, there's a break in our graph. This right here, we haven't talked about the different types of discontinuity in a graph, but this function happens to have what's called a jump discontinuity, because these 2 points here at x equals 2, we have this part right here, which is not included because of the open hole. So the ordered pair 2, 5 is not included. And here at the bottom, the point 2, 1 is included. So we could say 2 comma 1 here. This point is actually not an ordered pair, not included. And the point 2 comma 1 is included because of the closed hole down here, so we say is included. Okay, so if we're looking at this in terms of the domain, the first piece, the first function, its domain goes from negative infinity to 2, and 2 is not included because of this open hole again right here. And this piece down here, this piece of the function, with the line that goes downward and to the right, its domain is from 2 to infinity. Okay, remember, I'm describing the domain, which I'm only describing the x values here. A lot of people will say, Mrs. Hanson, why, if this arrow is pointed down, why are we going to positive infinity? Well, because we are only describing the x values, the range is going to be affected by the fact that this arrow is pointed downward, because we're going to go downward infinitely, which means the least y value is going to be negative infinity. Okay, and the same thing here, since this arrow is pointed upward, our highest y value is going to be positive infinity. So when I look at my domain here, the domain of my function, even though we have some discontinuity or a break in our graph, this hole is then picked up by this x value here at 2. So when I state my domain, I can say my domain is negative infinity to positive infinity only because this jump discontinuity, this hole here, jumps down and then is picked up by this closed hole at x equals 2. And our range is going to go from negative infinity to positive infinity as well, because this arrow is pointed downward to negative infinity. So like I stated before, our least y value is negative infinity, and our highest y value is positive infinity, because this arrow is pointed upward or increasing infinitely. In example 2, check for understanding. I want you to use the graph of f to find the domain and range of the function. We are given this graph right here of the function f of x, and f of x happens to be another piecewise function. And what I want to happen here is I want you to determine the domain, which is the set of x values, in the range, which is the set of y values for this function. You have 4 choices, A, B, C, and D, and I would like you to choose the correct answer and then press submit when you are finished.